Hello everyone. In this video we're going to be factoring out the GCF. So we're basically going to be using the skills that we formed in the last video of factoring the GCF, and we're going to use those skills to factor out the GCF. So first things first is, what are we doing? Well, we're basically going to be finding the GCF of, in this case, two numbers, and then we're going to divide those two numbers by whatever our GCF is. So what I always do, like in the previous video, is I always find the GCF of the number first. So we're going to find the GCF between 16 and 4. So we start with 1 and 16, give you a little gap, then we go up the number line. 2 goes into 16 8 times, 3 can't go into 16, 4 goes into 16 4 times, 5 can't, 6 can't, 7 can't, and we know 8 can't, or 8 can, so we stop right there. So then we do 4. 1 and 4. 2 and 2. We can't go any further, so we can stop there. So we realize that the largest number that these two have in common or the largest number these two numbers have is 4. So I'll circle that. We got 4. So GCF equals 4. But just like the previous video, we have to find the GCF between the variables. Alright, to do that, we always pick the variable with the smallest exponent. And in this example, we have the exponent of 4 and 3. 3 is the smallest, so that's going to be a part of our answer. So we have 4p to the third. Alright, so our next step is to divide both numbers by our GCF. So I'm going to rewrite. How about I erase this? So if you want to go back to find those numbers, you can just rewind the video. So I have 16p to the fourth plus 4p to the third. So I'm going to divide both of these numbers by our GCF, which is 4p cubed. 4p cubed. Alright, so we're going to divide 16 divided by 4, which is 4. Alright, and then we're dividing two variables with exponents. So if you don't know, when we divide variables with exponents, all we're doing is taking the top number and subtracting the bottom number. So 4 minus 3, so which is 1. So our answer is p to the first, or just p. So we have 4p. Alright, bring down the plus sign. And we notice 4p cubed over 4p cubed. Well, those are the same numbers. So if I had, let's say, for example, 4 over 4, we would say that's 1. Well, this same rule applies to numbers and variables. So 4p cubed over 4p cubed is just 1. Alright, now we're close to having our answer. So this is not our answer because we're factoring out the GCF. So the GCF is going to be involved in our answer. So whatever you get when you divide, you put that in parentheses, and then you put the GCF next to it, and that would be your answer. And that's it. That's all we're doing when we're factoring out a GCF. Alright, let's do the same thing with number 2. Okay, so we need to factor out the GCF between 63 plus 45b. I'm going to go out to the side and list my numbers. So 1 in 63. We know 2 can't go into 63, but let's see if 3 goes into 63. It does. 3 goes into 63 21 times. Alright, what about 4? Can 4 go into 63? Nope, because it's a decimal. All we're doing is, again, is taking 63 and dividing by the number we're trying to see if it will go into 63. Alright, we know 5 can't because 63 doesn't end in 0 or a 5. What about 6? Can 6 go into 63? No, because it's, again, a decimal. 7. Pretty sure 7 will. Yes, 7 goes into 63 9 times. And you should know that because of your times tables, because 9 times 7 is 63. Pretty sure 8 can't, but it's worth a try. 63 divided by 8. Yeah, we get a decimal, so it doesn't go. So we know 9 can, and to prevent ourselves from repeating ourselves, we can stop there. Alright, let's do the same thing with 145. We know 2 can, 3 can, I believe 3 times. 45 divided by, oh, what am I talking about? 18 times. Nope, 15 times. I'm acting crazy right now. 4 can't, 5 can. 5 can go into 63 9 times. Oh, I forgot to put my 5. 6 can't, 7 can't, 8 can't, so we can stop there. We pick the largest one between the two, and we realize that it is 9. Alright, so our answer is going to have a 9 in it. So GCF equals 9. Well, if we look at the other number, it says 45b. Well, you notice 63 doesn't have a b. So we can't have b involved in our GCF. So our GCF between 63 and 45b is just 9. Because in order for b to be included in our GCF, 63 would have to have a b in it. Therefore, it's basically saying that it's not common because b is not a part of 63 and it is a 45. It couldn't be common. So let's go to the next step. I'm going to erase this part so I can have a little more room. Let's see. Okay. Gotta love technology. You love it when it works, but you hate it when it don't. Alright, there we go. So, like in the previous example, we're going to take the numbers that we were given and divide by our GCF. And let me put that in orange. Divide both of these by the GCF. 63 divided by 9 is 7. Plus 45b divided by 9 is 5. But since we have that b, we have to include it because basically you when you divide 45 by divided by 9, you still have that b attached to that 45. So whatever number you get from the division, you have to tack on that variable, which is b. Alright, and then like in the previous example, we have to put our quotient that we got in parentheses, and then we tack on the GCF on the outside of the parentheses. And that's it. That's our answer. Alright. Let's see. Let's see if we could do two more real quick. Well, 6 and 6. Alright. Well, I'm not going to do the little GCF line that we've been doing because the largest number they have in common is itself, which is 6. So we're going to factor out a 6. But since both 6's are negative, we can factor out a negative 6. And to pick the GCF between the variables, we just pick the smallest one, which is r to the 4th. Alright. So we come over here, we do negative 6r to the 5th minus 6r to the 4th, and we divide by the GCF, which is negative 6r to the 4th, negative 6r to the 4th. Alright. So negative 6 divided by negative 6 is a positive 1. R to the 5th divided by r to the 4th. Again, we just subtract the numbers, which would leave us with r to the 1st or just r. Alright. And again, we have the same numbers. We have negative 6r to the 4th divided by negative 6r to the 4th, which is just 1. But since it's a negative over a negative, that becomes a positive, so we're going to plus 1. Alright, so I'm going to rewrite this as r plus 1. And let's form our answer. So we have r to the first, or r plus 1, parentheses, and then we have the negative 6r to the 4th, which is our GCF. And I should have mentioned this in the previous examples, but we can always check ourselves. We're going to check yourself, you just distribute, which means you're going to multiply this number by that number and this number by that number. So we have to multiply the number on the outside by every term inside the parentheses. So negative 6r to the 4th times r. So when you're multiplying variables, so let's say for example r times r, both of these have an understood 1. And in division, when we were dividing variables, we subtracted. So we do the opposite of subtraction, which is add. So we're going to add these two. R to the 1st times r to the 1st is r 1 plus 1, which is r to the 2nd. So in our example over here, we have r to the 1st times negative 6r to the 4th. R to the 4th plus 1 is r to the 5th. So we have negative 6r to the 5th times, or plus, no it won't be plus, negative 6r to the 4th times 1 is just negative 6r to the 4th. And if you get what you started with in the beginning of the problem, then you know you've done it right. So let's compare. The original problem, we had negative 6r to the 5th minus 6r to the 4th. And then over here we have negative 6r to the 5th minus 6r to the 4th. That's what we started with, and that's our answer. So we know this problem is right. Alright, last problem. We're factoring out GCF of 10 n to the 3rd minus 9 n to the 2nd plus n. Well, if you notice, in this problem, this n does not have a number. So we can't factor out the numbers in this problem because the last term does not have a number. But they all have a n. So, as we know, we pick the smallest the variable with the smallest exponent, which n by itself is understood as 1, so we can factor out a n. So GCF equals n. Alright, so again, we're just going to rewrite the original problem. And divide every single term by n, or our GCF. 10n to the third, so all of these have n to the first. When we divide exponents with variables, we subtract their exponents, so there's understood 1, 1, 1. Alright, 10 divided by 1 is 10. N to the third over n to the first is n to the second. We bring down the subtraction symbol. 9 divided by 1 is 9. N to the second over n to the first is n to the first, or just n. And then n to the first over n to the first is just 1. So we're going to bring down this plus 1. And then to complete our answer, we just surround it with parentheses, and we put our GCF on the outside. And that's it. And I hope you were able to understand what we went through in these 4 examples. And I look forward to helping y'all out with something else. So see y'all in the next video.